Hi guys, today we are going to be learning lesson 3.1. This is about relations and functions, and you guys will be able to determine whether a relation is a function by the end of today. So our first example is about recognizing domain and range, and our question is, what are the domain and range of the function? So if we look at our vocab first, it says a relation is a set of ordered pairs. So this table here can actually be written as ordered pairs. For example, 1, 11 is an ordered pair here, x comma y, 2, 12, and so on and so forth. A function is a relation in which each input is assigned to exactly one output. So the domain of a function is the set of inputs. This is our x values. Okay, the range of a function is the set of outputs. By convention, we usually just say inputs are x values and outputs are y values. So, what is the domain of this function? Well, it is our x values. And what is the range of our function? Well, this is our y values. Okay, we can also write this in our little curvy brackets. The domain of this function is the set of x values 1, 2, 3, 4, and 5. And our range is the set of y values. Now notice 13 is actually repeated, so we don't need to rewrite it that many times. We can just say 11, 12, 13. Okay, and a reminder, sets always use curved brackets when we are writing them, and the domain is a set and the range is a set. That's review from right at the beginning of the school year. So, for this next problem, go ahead and pause the video and identify the domain and the range and write them in set notation. Okay, hopefully you paused. Our domain here is 2, 3, 4, 5, and 6. And our range is 0, 1, 2, 3, 4. Notice the domain is the x values, and the range is the y values. Question 2, very similar. You've got your domain and your range. This is just really vocab, guys, but you're going to need to know what domain means, as in it's the inputs and the x values. So it is -3, -1, 1, 3, and 4. And our range is 1, 3, -2, 2, and 6. Okay? So domain is x values inputs. I know our vocab says it above, but it's probably a good thing to review. Domain is your x values and your inputs. The range is the y values and the outputs. Okay, so now we're going to analyze reasonable domains and ranges. So this says a function can model each situation with a reasonable domain and range of each function. So part A hose fills a 1,000-gallon swimming pool at a rate of 10 gallons per minute. So our inputs is a reasonable domain is from 0 minutes to the time it takes to fill the pool. So we're saying our x values are how long it takes. So domain would be from 0 minutes to the amount of time it takes to fill the pool. On the other hand, the range, we start at 0 gallons in the pool, and we have to get to 10,000 gallons, which is the capacity. So the range, what happens after that amount of time, the output is 0 to 10,000 gallons. Which is the capacity of the pool. Okay, so that is our pool example. The next example about chairs, a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So for the domain, our reasonable input or x values or domain is 0 tables to the number of tables needed. While the range, on the other hand, is our outputs, and in this case, it's going to be how many chairs we need. This one's a little different. It's not quite as all-encompassing as just 0 to 10,000 gallons. Our range is going to be multiples of 4 because we need 4 tables or 4 chairs at each table. Now, I'll say that we mostly won't do these like analyzing domains and ranges. We'll just be saying what the domains and ranges are. With that being said, we're going to continue on, and we're going to talk about some new vocab. Part 2 here of our analyzing. Is the domain for each situation continuous or discrete? So we've got 2 new vocab terms here. The domain of a function is continuous when it includes all real numbers. The graph of the function is a line or a curve. So you'll notice it just continues on and on. There's no breaks in our line. If the domain of a function is discrete, it just consists of whole numbers or integers. So it's like a scatter plot where we don't connect the line or the points, okay? It's just a series of data points. So you'll notice this guy on the right side, this is discrete. It is just data points not connected by a line. So this makes it discrete versus continuous, where it is just a line or a curve. So analyze each situation, identify a reasonable domain and range for each situation, and then explain. So you guys try that one on your own. All right, hopefully you tried this one on your own. I will say up here really quick before we move on that this first one is continuous. I want to make that definitely clear, while this one is definitely discrete. Okay, so this you try for the first one. It says a bowler pays $2.75 per game. We have our domain. Now, it has to be positive integers because a bowler cannot play a part of a game. They would still pay the full price for a game, even if they only played a couple of the rounds. And then you can't play a negative amount of games. Like if you're playing bowling, if you're going bowling, you're going to play a positive amount of games. So it is positive integers for the domain. And for your range, the output here is going to be multiples of 275 since each game costs $2.75. If he plays 2 games or she plays 2 games, it's going to be 275 times 2. So that is a multiple of 275. Go ahead and try the second one then. So the second one says a car travels 25 miles using 1 gallon of gas. So our domain here, our inputs are going to be all positive real numbers since a portion of a gallon of gas can be used. You don't have to buy even increments of gas. It's not just 1 gallon, 2 gallons, 3 gallons. You could buy 2.5 gallons. You could buy 5.46 gallons. You can buy a portion of each gallon. So then our outputs, our range, is all positive real numbers as well, since the car can go 25 miles per gallon and you can use any positive real number of gallons of gas. The outputs will be 25 times any positive real number. Okay, so that's more analyzing our domains and our ranges. Most of the time we'll actually just look at graphs and see what our domains and our ranges are. based on the x values and the y values, but we haven't gotten to that yet. So example 3, is each relation a function? If so, is it one-to-one or not one-to-one? So a function is called one-to-one if no two elements of the domain map to the same element of the range. Okay, so if no two x values map to the same y value. When two or more elements of the domain map to the elements of the range, the function is not one-to-one. So for example, if I write these guys out in a t-chart, so it's x comma y, they're just coordinates, 1, 2, 5, 6, 7, -1, 8, and 0. I basically just want to see if my x values are ever repeated. Because each x value is different, this is a function, okay? So we can say the relation is a function. And then to go beyond that, we have to decide if it's one-to-one or not one-to-one. And because every element of the domain, so I'm going to write that out, 1, 5, 7, and 8, maps to exactly one element of the range, which I will write out, 2, 6, -1, and 0. This is also one-to-one. Okay? Now, basically, big idea here. Just make sure your x values do not repeat. If they do repeat, this is not going to be a function at all. Okay? One more thing to add here. Since none of the range values are shared, the function is 1-to-1. Okay, so if we look at the next one, it's very similar. You can go ahead and make an XY chart if you want. We know 1 goes to 17. We know 2 also goes to 17. We know 3 goes to 11. 4 goes to 10. And 5 goes to 10. So first things first, you want to see if there is any x values that are repeated. I know there is not. 1, 2, 3, 4, and 5 are all different. So the relation is a function. You can say every x value goes to one y value. So the x value 2 doesn't both go to 17 and 10. That would make it not a function. Okay? This one is a little different than the last one, though. Because there are repeated y values, this is a not one-to-one function. So I'm going to write it out. Since more than one element in the domain maps to a single element in the range, the function is not one-to-one. So give me a second. I'm going to write that out. Okay, so big idea here. If it is a function, you do not have repeated x values. If it is one-to-one, you do not have repeated y values. Okay, that's basically what you're looking for. Repeated x values means no function. Repeated y values means not one-to-one. So go ahead, you guys try these next two. Pause me, try them out, see what you get. All right, on this first one, hopefully you guys have that this is not a function. Okay, we have a repeated x value that goes to two different y values. See how 3 points to both 6 and 7? This means it's not a function. We cannot have this happening. The reason this is if I were to graph these 4 points, I have -2, 5. I have 3, 6. I have 3, 7, and I have 4, 8. Now, I was going to talk about it on the next one, but I'll go ahead and talk about it here too. We have something called the vertical line test. Okay? If you can draw a vertical line and it crosses more than one point at the same time, this means that it is not a function. Okay, I don't think I can really show you guys, but if you, like I have here, can cross more than one point at the same time, this does not pass the vertical line test, which means it is not a function. So graphically, that's what it looks like. On a table, you just look for repeated x values, and then you know it's not a function. Okay, and then if it's not a function, it can't be one-to-one or on-to. So because, I'll just put a little because here, 3 maps to both 6 and 7. So that's why it doesn't work. Okay. For the second one, though, this is a function because, like I was saying, the vertical line test, we can check. And because this vertical line here can be moved and only crosses the red line at one point at a time, this is considered a function. Okay, and then you can check the horizontal line test to see if it is one-to-one or not. If it passes the horizontal line test, then it is considered one-to-one. So it is one-to-one. Okay, now if I were to give you an example of one that would not pass this, if I draw something like this, which we will get to later in the year, if I have a vertical line that I test here, notice how my vertical line crosses my purple function in more than one spot. So this guy is not a function. Okay, so that's the difference. That's how you know if it is a function or isn't on a graph. All right. Next example, we have example 4, our last one. We are going to identify constraints on the domain. So the diagram shows shipping charges as a function of the weight of several online orders. Based on the situation, what constraints, if any, are on the domain of the function? Now notice inputs here are what I just pointed at. A restriction on our domain here is something like you have to have some sort of weight if you're going to send something. You can't just send air without any packaging because the label would still have weight. So an order must have a weight greater than 0 and it doesn't really have a top end. I mean, you probably wouldn't want to ship like a couple tons of things, although I'm sure it's possible. So we go ahead and say that the domain of the function is confined to values greater than 0, and that's it. So guys, on these ones, you kind of have to get out of your math brain head a little bit, and you have to think more about things logically, like how the world actually works. Like the idea of shipping a package has to have weight. It can't have negative weight or no weight at all. That's how you think about your like domain inputs and range outputs. Okay, and lastly, this you try. It says Margaret has a monthly close budget of $50. She maps the amount of money she spends each month to the number of items of clothing she buys. What constraints are there on the domain? So you guys can go ahead and work on that one. Okay, so since Margaret is mapping the amount of money she spends each month to the number of items she buys, your input or your domain is going to be the money spent, which then maps to your output y, which is number of items. Not that it asks for that, but that might help you with considering what your domain is. And you'll notice that I have written that all numbers in the domain must be between 0 and $50. She could spend no money on clothes one month, and then the next month spend her whole budget of $50. But she is set, so she won't spend more than that, and she can't spend negative money on clothes. Okay? So that is it for 3.1. Go ahead and work on the 3.1 worksheet. Yeah, have a great day.